Okay, today we're going to be talking about section 1.5. Section 1.5, sorry, is all about combinations of functions. So basically what we're going to do today is we're going to add, subtract, multiply, and divide functions, simplify them completely, and find the domain and range of those functions as well. Going to do some compositions with that as well, plugging one function into another function. And a lot of this is review from Algebra 2, so it should not be that bad. So f of x is 2x plus 1, and g of x is x squared plus 2x minus 3. That is the given function. So the first thing I want to do is I want to add those two functions together. So all I'm going to do is I'm literally going to take f, which is 2x plus 1, and I'm putting that in parentheses, and then I'm going to put the next function, which is g, and I'm going to put that in parentheses too, and we're going to add those together. So since we're adding the two functions, I don't need to distribute anything, so I can simply drop the parentheses. So 2x plus 1 plus x squared plus 2x minus 3. So from there, I'm going to combine like terms. So the x squared drops down, I cross that off. 2x plus 2x gives me a 4x. 1 minus 3 gives me a negative 2, and this is completely done then. Okay? Now, over here, I'm going to be subtracting those functions. So we're going to do exactly the same thing. I'm going to have f, which is the 2x plus 1, minus the g, which is the x squared plus the 2x minus 3. But the difference between the first example and the second example is that the two functions are attached by subtraction. So I have to drop the parentheses around the first one, but distribute the negative into the second one. And if you do not distribute the negative, you will get these problems incorrect. So again, I'm going to combine like terms, drop down the negative x squared, the two x's cancel out, and I'm going to be left with a minus x squared plus 4. So that is adding and subtracting the two functions together there. And then that is done. Okay? The next one is going to be going ahead and giving the same two functions, but this time they're attached by multiplication. So this is going to be 2x plus 1 times x squared plus 2x minus 3. And since there are two parentheses attached by multiplication, we're going to be foiling. It's not technically FOIL because it's not a binomial term times a binomial term. It is a binomial term times a trinomial term. So we're going to take and distribute the 2x to each term in there. So that's going to be a 2x cubed plus a 4x squared minus a 6x. Then I'm going to go ahead and distribute the 1 to give me an x squared plus a 2x minus a 3. And then from there, I'm going to go ahead and combine like terms. So this gives me a 2x cubed that I drop down. Then I have 4x squared plus x. That's going to give me a 5x squared. I'm going to cross those off as I go. Negative 6x plus 2x is going to be a minus 4x. And then drop down the minus 3. And this is completely done. That is multiplying. Now, the next one we want to do is we want to actually divide these two functions. So if I'm dividing these two functions, I need to go ahead and I need to keep them in parentheses like we did before. So this is going to be the 2x plus 1 over the denominator of x squared plus 2x minus 3. Now, if I'm dividing these, basically what that means is I need to go ahead and factor the denominator completely. So that's going to be an x and an x. Factors of 3 are 1 and 3. I don't have any other choice to use 1 and 3. But I need a negative 3 but a positive 2. My positive 2 means that my larger term, which is 3, must be positive and my 1 must be negative. So my question is if I'm simplifying this, can I do anything else with that? And the answer to that is no, I can't do anything with it, but it wants me to give the domain. The domain is found by taking the denominator and factoring it completely and going ahead and finding what it cannot be. So the domain of this function is found by taking x minus 1 cannot be 0 and x plus 3 cannot be 0. It's taking the factored form. So x cannot be 1 and x cannot be negative 3. So x is an elm of the reals and x cannot be the value 1 and negative 3. And that is the domain. Sorry, did not mean to change that as quickly as it did. Okay? So, moving right along, same exact concept, okay? But now we're going to be adding the two functions together. So let's go ahead and do this one. That's going to be x squared plus x minus 3. I don't need parentheses, so because I'm adding the two functions together, I can just simply attach them by addition. So this is as far as it can go. Okay, but now I want to take that f plus g And I want to plug every place I see an x, I want to plug in the value -5. So I'm literally going to work from this. So that's going to be an x squared plus x, and every place I see an x, I plug in the value -5. So that's -5 squared plus a -5 minus a 3. -5 squared is going to be 25 minus 5 minus 3. That's going to give me a 20 minus 3, which gives me a 17 as my final answer. So here's the thing. I took two functions and I added them together. Okay? After I added them together, I then plugged in the evaluation, what of -5 in for them, and I calculated out the answer to give me that when I evaluate f plus g at -5, it is the value 17. So when you plug in a number, you're going to get a number out. So what happens whenever I plug in an expression? Well, I'm still going to use the x squared plus x minus 3, but every place I see x, I'm now going to plug in -t plus 4. Now, this -t plus 4 squared, you actually have to write that down twice and FOIL that. I'm going to drop parentheses here because I don't need them. And I'm going to make this a little bit bigger for us to see. Okay, so now I'm FOILing. So -t times -t is going to be positive t squared minus a 4t minus a 4t plus a 16 minus a t plus 4 minus 3. Drop down the t squared. -4 and -4 is -8. Minus t is going to be -9. So I had talked about all of those. 16 plus 4 is 20. Take away 3 is going to be 17. So when you plug in an expression, you get an expression out. Okay? Composition. Composition is basically what I just did. It's plugging in an expression for another expression and getting a whole new function out of it. Okay? So here's what I have for you. I give you f of x equals 3x minus 1, and g of x is equal to x squared plus 1. This says right here, g of f of x. You know what that means? That means you're doing g at f parenthesis of x. You're putting f of x in place of g of x. You're putting f of x in place of the x in g of x. So that means I'm going to take my g function. My g function is x squared plus 1. Well, my x function goes right here because that's what f is defined to be. F of x is 3x minus 1, which is why I'm putting f in place of g. So now I'm going to take this right here, and I'm going to plug it in for x. So that's going to be a 3x minus 1 quantity squared plus 1. I'm going to write that down twice and FOIL. Three x times 3x is 9x squared. Minus a 3x, minus a 3x, plus a 1, plus a 1. So 9x squared minus 6x plus 2. That is what g of f at x is. Right there. Now I want to know what f at g of 2 is. Well, this is really tricky. You work from the inside out. So if I work from the inside out, I'm going to do g at 2. So I'm going to take my g function, which is x squared plus 1, and I'm going to plug in 2. 2 squared is 4, plus 1 is 5. So that means g at 2, which is right here, is also known as 5. So that means I'm going to do f at 5 now. That means I'm going to take my f function, which is 3x minus 1, and I'm going to plug in a 5 for that. So that's 15, take away 1, which is 14. So that means f at 5 is 14, and guess what, folks? This right here is the final answer. That's what we're looking for, okay? Let's do this again. One more time. F of g of x is the same thing as f little o of g of x. So they can be substituted for each other. Lots of people do not like this notation. They prefer this notation, green for go. Do we all understand that? Okay? So we are going to work from the inside out. The inside out says I'm going to do g at 2 first. G at 2. Well, g is defined to be x squared plus 1. So I'm going to simply put in 2 for x. 2 squared is going to be 4, plus 1 is 5. That means g at 2 is 5. G at 2 is 5. So every place in the original problem that I see a g at 2, I can replace that with the number 5 now. So g at 2 is equal to f at 5. So now I'm going to take my f function, and I'm going to evaluate my f function, which is 3x minus 1, at the value 5. So that's going to be 3 times a 5, which is 15, minus a 1, which is 14. 14 is a great number today, apparently. And again, that is going to be the answer that we are looking for, okay? Now, this is going to be a little different, because now I want to know what f at g of x is. Well, this notation is the notation that I said no one really likes. So we're going to go with f parenthesis of g of x. Do I know, remember I said I work from the inside out, do I know what the inside is? The inside is g of x. Do I know what g of x is defined to be in the directions? Sure I do. In the directions, g of x is x squared plus 1. So what I'm actually calculating is f at the g function, which is defined to be x squared plus 1. So that means I'm simply going to take my f function, which is now 3x minus 1, and I am going to plug in x squared plus 1 for x. So that's 3 parenthesis x squared plus 1 minus 1. And I'm going to distribute 3x squared plus 3 minus 1 and combine like terms. And I am done. When I plug in an expression, I get a new expression out. F of x of g of x had a variable inside there. So whenever I calculate this, it should have a variable in the answer still. Okay? Same concept. Prove that f of g of x equals g of f of x. So I want you to do reverse compositions both ways. So I'm going to do f, sorry about that. I'm going to do f of g of x. And over here, I'm going to do g of f of x. Okay? So if I'm going to do f of g of x, that means I'm going to do f at 1/2 parenthesis x minus 3. Why? Because that's what g is. So my function is 2x plus 3. Now I have to plug in my values. So that's going to be 2 parenthesis 1/2 x minus 3 plus 3. Okay? The 2 and the half cancel out, so I'm left with x minus 3 plus 3. So I'm left with just x. So f of g of x is equal to x. Now I have to prove that g of f of x is equal to x. So that means I'm going to be doing g at, well, what is f of x? 2x plus 3. So my g function is 1/2 x minus 3. So that's going to be 1/2 times 2x plus 3 minus 3 close parentheses. The 3's cancel out and you're left with 1/2 times 2x. The 2's cancel out, so you're left with x. So what we just proved is that f of g of x is equal to g of f of x. They both equal x. That makes us very happy. That's what the directions told us to prove. Okay? Now, what is f of g at 0? Well, that's a funny concept because guess what? It's the same two functions. And I already know that I already know that f of g of x is equal to x. So f of g of 1 is just going to be 1 because I'm plugging in 1 for x, or 0 for x. I just plugged in the wrong number, sorry. Okay? Meaning, it doesn't matter what I plug in there. F of g of 2 is 2. F of g of negative 10 is negative 10. Why is that? Because they equal x. They equal x, which is pretty darn cool. Okay. Reverse composition. Reverse composition is very, very, very cool. Reverse composition says, I want you to come up with two functions that whenever I do the composition of them, it gives me this new function, h of x, which is right here. Now, you kind of have to think backwards. So you have to find two functions, f of x and g of x. And I want you to find it so that when f of x of g of x has to equal h of x. So that means my inner function is going to be g of x. And then if I get rid of x minus 2 and replace that with x, oh, come on. I keep hitting the wrong thing, y'all. It will give you h of x. So how do I show that? F of g of x. So that's f of x minus 2. So that's going to give me 3x squared plus 5 is what I said was f. And I'm going to plug in x minus 2. So I'm right. The inside term, whatever's in parentheses, is going to go inside. So let's do it again. I want to prove that g of f of x. So that means g of f of x. F of x is the inside function. So what's the inside function? The inside function is 4 minus x. So the inside function is f, so that's 4 minus x. So that means the outside function is going to be the square root of x plus 7. Is that the only thing that could have worked? Nope. Another thing that could have worked is make the whole thing 4 minus x and then make this x plus 7. There's multiple solutions to this. Okay, so you're just going to work from inside out. Same thing here. F of g of x is the inside one. So what's on the inside? X minus 4. So that's going to be g of x. So if x minus 4 is on the inside, then what's left to be f of x? 5 times the absolute value of x plus 3. Is that my only option? No. Maybe you saw this one. Remember I said you could take the whole thing? You could say that this is going to be 5 absolute value of x minus 4. And then that's going to be just simply x plus 3. It just really depends. Another one you could have said is that it could have been the absolute value of x minus 4, and then you could have had this be 5x plus 3. Those are 3 different possibilities you could have done. Okay? Now, that tells us that tonight's homework is going to be 1-5 worksheet 1. This was a longer lesson, and where you're going to probably struggle is going to be the reverse combinations, the reverse composition. So if you have questions, please let me know.